All right, we want to talk about how to calculate the empirical and the molecular formula of organic compounds, and I want to do it in a question form. When 0.684 grams of an organic compound containing only carbon, hydrogen and oxygen was burned in oxygen, 1.312 grams of carbon 4 oxide and 0.805 grams of water were obtained. What is the empirical formula of the compound? Now you see here we have the product, which is carbon 4 oxide, and another product is water. So from carbon 4 oxide we want to get the mass of carbon only, and from water we want to get the mass of hydrogen. So how do you do that? So the answer is that the mass of carbon is calculated by, you take the mass of carbon, which is 12. Carbon is atomic number 6, therefore the mass number is 12, so it is 12. And then the total mass of carbon 4 oxide is 44. How do you get that? It is oxygen 16 times 2, which is 32, plus 12, which is 44. And then times, you multiply the total mass, the total mass of carbon 4 oxide, and then now you are able to get the mass of carbon only. You are able to get the mass, and as you can see, this one is the mass of carbon. Next one, we want to, how do you get the mass of hydrogen? We know the mass of hydrogen is in water, so, and the total mass of water is 0.85. So, but we know the mass of hydrogen only is 1. Hydrogen is 1 times 2, which is 2. So we have 2. We have 2 over the total mass of water. It is 18. That is 16 plus 2 times 0.805, and it will give us this 0.89. That is now. Now the mass of oxygen is calculated. How do we get the mass of oxygen now from what we have here? Remember, the mass of the organic compound was 0.678, but now we have the mass of carbon and we have the mass of hydrogen. What is remaining is the mass of oxygen, of oxygen, yes. So how do you get that? To obtain the mass of oxygen, you subtract the total mass, you subtract the mass of carbon and the mass of oxygen, the total mass of carbon and oxygen, from the original mass. Remember, we add 0.684. This was the original mass. Now this subtract this one, you get 0. You get 0.245 grams, and that is the mass of oxygen. Now once we have obtained the mass of oxygen, carbon and hydrogen, we go to the table and we put carbon, hydrogen and oxygen, mass in grams. Mass for carbon was 0.35, that and that. RAM of carbon is 12, RAM of hydrogen is 1, RAM of oxygen is 16. Now the next one is the number of moles. This one is the number of moles. You know this number of moles. Number of moles. How do you get moles? Moles is equal to mass of RAM for RFM. It doesn't matter. For this one is RAM. So 0.35 divided by 12. This is the answer. This one, the answer is here. And then the next thing is the mole ratio. How do you get the mole ratio? Once you have calculated the number of moles, check the number of moles you have. Take the one that is smallest. Take the number that is smaller among all the moles. Now you check these moles here, check these moles here, and check this one. The one that is smaller, or has the smallest value, you divide that number of moles throughout. So as I can see from here, 0.1 is the smallest. This one is the smallest. Therefore, you divide by this through all the number of moles. That's why we divide 0.0 divided by this, we get 1. 0.84 divided by this smaller moles, you get 6, and that's how we get the moles, or the number of moles. Now the ratio, the mole ratio. You take, once you have gotten your number of moles, you check, you look at the number of moles you have obtained. The one that is the smallest, you divide it throughout the number of moles that you have calculated. So after doing that, and this is now our empirical formula. This is now our empirical formula. C2, carbon now there are 2, hydrogen there are 6, and oxygen is 1, so we don't write anything there. And that is the empirical formula. Let us go to another question. An organic compound X containing only carbon, hydrogen, and oxygen was subjected to elemental analysis by complete combustion method. It gave 0.228 grams of carbon dioxide and 0.632 grams of water. Determine the empirical formula. We will do the same. We have the total mass of carbon dioxide. Therefore, from carbon dioxide, we need carbon. We will calculate carbon from carbon dioxide. That is why we use 12 divided by the total mass of carbon dioxide times the total mass of carbon dioxide, right? That is the array. And then with it means that the mass of carbon only is 0.11. The mass of hydrogen can be calculated as follows. Hydrogen here, as you can see, there are 2 atoms, so it is 2 over the total. Total is 18. 18. How do you get 18? It is 16 plus 2. Oxygen is 16. Hydrogen is 1 plus 1, which is 2, 18. So 18 times the total mass. The total mass of water was 0.632. Therefore, the mass of oxygen only is 0.0702. How do you get the mass of carbon oxygen now? That is the one which is remaining. It is the total mass, subtract mass of carbon dioxide plus mass of hydrogen. That is correct. Now we have the mass of hydrogen. We have the mass of carbon, right? But we know oxygen is in this carbon and oxygen is in this water. So if we add the mass of hydrogen, add the mass of carbon, and then subtract from the total, we get the mass of oxygen. I think it is clear after you have done that. Now you come here, you write the carbon, hydrogen, the same we have done. Mass in grams is 0.1, like that. RAM 12, 1, 16 for oxygen. Number of moles. Now moles is mass of RFM, that is 0.11 divided by 12. You get this. Yeah, you get this one. And then 0.07, like that. So now we want to go to more ratio. That is where so many people have a challenge. So once you are in the mole ratio, look, check on this number of moles. Number of moles here. Check there. Number of moles. Check here. Number of moles. The number of moles that has the smallest value, divide that value throughout the number of moles. Therefore, the smallest one I can see is 0.09. This is the smallest, because this one is 0.7. This one is 0.0. Therefore, this is the smallest. So you divide it by that. That is 1. This one will give you 7, and this one will give you 4. Therefore, the empirical formula of that organic compound is this here. C1, H7, and oxygen is 4. Very correct. Very good. The next one, in an experiment, 3.1 grams of a compound of carbon, hydrogen, and oxygen produced 4.4 grams of carbon dioxide and 2.7 grams of water on complete combustion. Determine the empirical formula of the compound. Carbon is equal to 12, oxygen is equal to 16, and hydrogen is equal to 1. So the mass of carbon, like we have done the rest, we get the mass of carbon from the total mass of carbon dioxide and the mass here is 4.4, so we multiply, we get 1.2. The mass of hydrogen here is 2 over the total times 2.7, and then mass of oxygen is the original, this total here. This is the total we had used. This is the total, and that is what we are using here, the total. Subtract the mass of carbon plus the mass of hydrogen, we get 1.6, and this is the mass of oxygen, the mass of oxygen. Now we have the mass of oxygen, carbon and hydrogen. We bring it into a table, and then we have it like this. Now I want to also again to see the mole ratio. The smallest number of moles here is 0.1, so we divide by 0.1 both sides all through, and you get the mole ratio. After that, you get the empirical formula as that. That is the empirical formula. When a certain hydrocarbon is burned completely in oxygen, 5 of these grams and water were formed. If the molecular mass of a hydrocarbon is 84, determine the molecular formula of the hydrocarbon. Now here we want to calculate the molecular formula, but we have the molecular mass. Our molecular mass is here. That is very correct, very easy to do it. But first we will do the same thing we have done. We know we have 5.28 grams of carbon dioxide. If that is carbon dioxide and we want, remember, an hydrocarbon. An hydrocarbon is a compound that is made up of hydrogen and carbon only. So here we don't need oxygen, we need carbon and hydrogen. So from carbon dioxide we will obtain carbon 4. From water we are going to obtain hydrogen. That is what we want. So the mass of carbon is 12 over 44 times the total mass, which will give us 1.44. Mass of hydrogen is 2 over 18 times that, and it will give us this. First, we must get the empirical formula before we go to molecular formula. So we will calculate the empirical formula like we have done the rest. So element, carbon, hydrogen. Remember, an hydrocarbon contains only carbon and hydrogen. So mass in grams, it is 1.44, and that RAM is 12.1. Number of moles, 1.44 divided by 12, it will give you 0.12. 0.24 divided by 1 is 0.24. Then mole ratio, the smallest here is 0.12, so we divide by that both sides, here and there, and it will give us 1 to 2. It means the empirical formula is here, and this is the empirical formula. But that's, we don't stop there, because the question asks us to calculate to determine the molecular formula. We have the molecular mass, but we know that empirical formula times N will give us the molecular mass. So we have the empirical formula, we are going to multiply it with N, and then it will give us the molecular mass. So we are going to determine the value of N. So our empirical formula is CH2 in bracket times N, which will give us is equal to 84. Carbon is 12, hydrogen is 1, and then 1 times 2 is 2, so 12 plus 2 is 14. So 14N equal to 84. You divide both sides by 14, you get that the value of N is 6. So if the value of N is 6, so you come back here to this. If you put 6 here, if you put 6 there, then you will multiply 6 times C will be 6C, and then 2H2 times 6, it will give you 12, and this is the molecular formula. That is what the molecular formula. I have another last example here. I think this is the, no, this is not the last one, the second last. Hydrated salt of copper has a formula of copper sulfate dot N waters. About 25 grams of the salt was heated until the water evaporated. If the mass of the anhydrous salt is 16, find the value. Remember, anhydrous, hydrated and anhydrous. Hydrated, it contains water of crystallization. Anhydrous, it does not contain water of crystallization. So if you heat copper 2 sulfate, which is hydrated, this water will evaporate, and once it evaporates, we will remain with anhydrous copper 2 sulfate. So now the mass of copper sulfate anhydrous, we have been given it is 16. That is 16. We have been given that from the question. But we were given that the mass of hydrated, while it contained the water of crystallization, the mass was 25. So we can easily get the mass of water that evaporated. How do you get that? The mass of water is equal to hydrated salt minus anhydrous, right? The one that when it was hydrated, you subtract anhydrous, you get that the mass of water is 9. So we take these values to the table. You write now here the compound. Actually, this is not an element, but now it is the compound. This is the compound. So the compound here is copper sulfate, and then we have water. This water is also a compound. The mass of the copper sulfate is 16, and the mass of water that evaporated is 9. We want the value of N here. We are looking for this value N. So the Rm of copper 2 sulfate, we have been given here, remember, copper is 64, sulfur is 32, oxygen is 16. So what you do, you just add here, you take copper is 64, so it is 64 plus what? Plus 32 plus 64 times 4 is 16 times 4 is 64. So if you add the 64 and the total will come 160. You do the same to water. Water is 16. 16 plus 2, it is 18. So that's how we get the Rm. Now this is here. Now it's not going to be Rm, but the Rfm. You should know the difference. This is now the relative Rfm. Rfm. This one is going to be Rfm and not Rm. Relative formula mass, because this is a formula, this is a compound, a formula. So we call it relative formula mass, Rfm. The rest we were using Ram because relative atomic mass, this is an atom, so it is an atomic mass. But for this one, it is a compound. We use Rfm, relative formula mass. So 160 and that one is 18. So when we go to number of moles, this one is 16 divided by this is 0.1. 9 divided by 18 is 0.5, and that is how you get the mole ratio. So once we have the mole ratio, it means the value here, the coefficient here is 1, and the coefficient of water here is 5. Therefore, the value of N is 5, and that is how you calculate that. Therefore, the value of N is this 5. A compound of carbon, hydrogen, and oxygen contains 57%, 51.1% carbon, 4.6%, and the rest is oxygen. If its relative molecular mass is 126, find the molecular formula. Find the molecular formula. So there, what is made there is that carbon, what is missing, carbon is equal to 12. That's what is missing. Oxygen equal to 16. But these are the things you need to know. And then the next one is hydrogen equal to 1. You need to just know. So the mass of carbon here, we have been given in percentage. So mass in percentage for carbon is 57.15. Mass of hydrogen, we have been given 4.76. How do you get the mass of oxygen? Because you have been given the rest. Because it is in percentage form, anything that is in percentage form, the total percentage is 100. Therefore, when you add, you get 100. So it is 100 minus this and this. It will give us that. So this one is supposed to be a plus. So when you plus this, you will subtract from 100, you get 38.09%, and that is now the mass in percentage of oxygen. You take this information to the table, and then you calculate the empirical formula. Once you get the empirical formula, you calculate the molecular formula. So the empirical formula is here. We have done that. I don't want to repeat a lot. Since the molecular formula is 126, then the empirical formula times N should give you the molecular mass, and the molecular mass is 126. Our empirical formula is C2H2O, and that is what we have here. So 1 carbon is 12, so 12 times 2, it is 24. This one is 24, plus hydrogen 2, plus oxygen 16. The total will give us 42. So 42 times N, it will be 42, N equal to 126. Divided by both sides by 42, and it will give us that the value of N is 3. Therefore, the molecular formula of this organic compound is C6H6O3. How did I obtain that? You take this compound here. Once you have that compound, you do what? You take now, instead of 3N there, you put a 3. Once you have 3, you multiply this 3, everything inside. So we have another bracket here. You multiply. So 2 times 3 times 2 here, it becomes 6. 3 times 2 here, it becomes 6. And then this here, there is 1. There is 1 there. So 1 times 3, the answer is 3. And that's how the formula is formed. So like that. Thank you. Thank you very much. Remember to subscribe. Thank you.